Let's now look at this review problem. State the division algorithm for polynomials. I'm not asking you to prove the division algorithm for polynomials, just to state it. And the statement was given in the class notes, and so let me just put that on the screen now. Suppose that a of x and b of x are polynomials over a field. So the notation f square bracket x means that the coefficients of a come from the field f. And examples of f could be polynomials with either rational coefficients or real coefficients or perhaps complex coefficients. Those are the most common fields that we think about in the secondary curriculum. Of course, there are other fields besides these, but that's z square bracket 2, for example, z square bracket square root of 2, for example. But these are the most common fields that come up in these secondary curriculum. So we have polynomials where we use either, say, rational numbers or real numbers or complex numbers for coefficients. Then there are unique quotient and remainder in the same field, so that a of x is equal to b of x, q of x plus r of x, where either r is the zero polynomial or the degree of r is less than the degree of b. And I forgot to say earlier that we have the important assumption that b is not the zero polynomial. So this has the same qualitative form as the ordinary division algorithm for integers. A is equal to bq plus r for ordinary integers, and r is somehow smaller than b. In this case, the degree of r is smaller than the degree of b. Or r of x could be the zero polynomial, because the zero polynomial does not have a degree. A constant polynomial, a non-zero constant polynomial has degree 0, but the zero polynomial by definition does not have a degree. So that's why we have to have these two cases in the statement of how r is sized, so to speak. So the important properties: a and b are coefficients. A of x and b of x are polynomials whose coefficients belong to some field. And b is not the zero polynomial. Then there are unique polynomials q and r in the same field, so that the a of x is equal to b of x, q of x, a of x is equal to b of x times q of x plus r of x, and r of x is either 0, identically 0, or the degree of r is less than the degree of b.